Hello, this is a short video which will demonstrate how my external PTT microphone and programmable function array is working with my Kenwood TS-590SG. So as I have shown on my blog, the inside of this box contains a very simple circuit which provides a biasing network, DC bias network for the microphone, external microphone, and also how you can add the 4 programmable function buttons to control Kenwood 590SG. On this box I have several switches. This one and this one, these two actually, are for the PTT in 3 different ways. I've done it because it's convenient from my point of view. So this PTT, this is switch that goes up, stays up and then down, and you have to keep it pressed. I'll show you how it works. These 2 buttons is for the up, that's for the down, and this keypad here from 1 to 4 is actually used to program the 4 programmable function options the way you like through the Kenwood 590SG menu. So let me see how this works. So when I press this, 1, 2, audio check, checking audio, audio check, and then I have this as well. So when I push it down, audio check, audio, checking audio, and I let it and it goes back. When I push this switch up, it remains up, and you can see that the PTT function stays locked. Audio check, audio, 1, 2, checking audio check. So it stays on the PTT function locked until you push it and you bring it back to the reset position. Over here is the microphone. I'm using some ordinary PC headphones. This is a capacitive microphone, so let me just put it down a little bit. And on these 4 functions I have chosen this one to be calling channel 1. So when I switch back to CW, I'm pressing this, so it automatically activates channel 1. It's more convenient to do it through this area than moving your finger over there. Number 2, I have chosen it to be the IF, the width of the IF filter. So when I press number 2, okay, let's go here. You can see how I'm changing from filter A to filter B. So this is number 3 is for the noise reduction. Number 4 is the send button. This one actually is like a PTT that stays locked. Instead of using the switch, you can use this one. Okay, those 4 are depending on your personal selection. Over here it's the microphone jack. This is the cable that goes to the microphone connector. It's a 6 cable. It says here, you can read it, number 6. Contains 6K. Oh, it's not visible, is it? Cannot focus actually. Okay, 6 cables, 0.14 millimeters diameter, plus the external foil. There's an external foil around those 6 cables underneath this insulator that is used for the microphone ground. Bear in mind that there are two different grounds over here. The one is for the microphone ground and the other one is for the transceiver ground. These are two separate grounds which you must keep in mind when you design such a microphone thing. So I have over here I have the circuit which I have uploaded on my blog, so you can download it from there. This is used to control more or less the current that goes into the microphone, and it also controls this low pass filter here, this from the plus 8 volts of the transceiver. There are two potentiometers that are used to adjust the DC bias voltage that supply the microphone. Why I have two? I have two because you can also adjust in a way the impedance matching between the microphone and the VCC if you ever need to do so. The microphone side of the transceiver goes through decoupling capacitor to the microphone. This network here has a potentiometer of 20K in parallel with 47 nanofarads. This one actually controls the low frequency response of the microphone, which can be excessive when you are using ordinary capacitive microphones. Okay, I chose 1 microfarad as a DC blocking capacitor, but later on I realized that I can actually choose a 47 nanofarad. This actually enhances the low frequency response of the audio. It gets rid of low frequency distortion that might be caused. Okay, I mean, you could actually adjust this through the system, but 47 nanofarad I just realized is not a bad choice compared to 1 microfarad. You still have an acceptable audio quality. Okay, so I also have the PTT button, the up button. This is programmable function 1, programmable function 2, 3 and 4. You need to take care of the series resistors, so you make sure that 22K connected through the switch on the up button activates number 1 and so on. The down button, you have number 3 PF with 22K and number 4 with 100K in series with the control switches. So 1, 2, 3, 4, these 4 functions are actually these ones here. The down button and the up is actually this one and this one respectively, and the PTT, these two PTTs here, is actually this one. So it's a relatively simple circuit, nothing special. I mean, I just realized that it's best to DC bias your microphone with 5 volt DC Okay, you can go between 4 and 6, but 5 is something that works best for me. This 100 picofarad capacitor is connected in parallel with the microphone, so I think I should have put here, this is mic ground. It's not system ground, just make sure that this ground here and this ground here are two different things. Don't mix them up. You need to keep them separate. So this 100 picofarad capacitor is used to avoid any high frequency RF frequency noise that might be picked up from the microphone. Ideally, it would be best to solder this as close as possible to the microphone case. Okay, I just put it on the PCB, but I should have put it here, but it was convenient to put it on the PCB instead of the microphone, so the 100 picofarad is inside this box and not on the microphone of my headphones. Some people also put a ferrite bead near the microphone to suppress any extra noise that might be picked up from the microphone or the foil, the ground foil, or elsewhere on the system. Okay, so this whole setup works for me on my Kenwood 590SG. I hope this video was of some use to you and hope to speak to you again soon. Bye bye.